Welcome back. Now we'll be beginning chapter 2 of how to design your own microcontroller board. So in this chapter we'll be looking at power supply. How do we make sure that the microcontroller receives stable power, right? Microcontroller cannot be receiving uh, sine waves or jagged power. It needs to have stable power. Are there any recommendations given by the microcontroller manufacturers itself on the datasheet? What are the clock and oscillator designs that they recommend? Are they recommending anything else that will needs to be taken care? That's what we'll be looking in this chapter. So this chapter will be purely looking at the datasheet and understanding what are the power supply requirements and the clock and oscillator design. So traversing to the datasheet, here let's quickly look through what it talks about. So this particular diagram here, it gives us LDO requirements, voltage regulator 5 volts to 3.3 volts. So earlier we had seen in the electrical characteristics the maximum voltage that we can provide it as 5.5 volts, a stable 5.5 or even 3.3 volts, right? So we'll go through this again. So here it is talking about an internal LDO which can convert 5 volts to 3 volts, but we have to make sure that the microcontroller receives stable 5 volts, that is on the external end of the chipset. It cannot be made internal to the chipset itself. So here are there any power? Yeah. So clock, it talks about built-in 24 megahertz clock source which can support external crystals by multiplexing GPIO pins. So this is internal clock source, right? Then power, built-in 5 volts to 3.3 low drop voltage regulator. It supports 5 or 3.3 voltage supply voltage, supports low power sleep mode and external wake up of USB UART, so and so, right? So this works on 5. It talks about built-in LDO, right? Nothing on power requirements. Power requirements comes a bit down. VCC, power input requires an external 1 microfarad power decoupling capacitor. So as the rule of thumb, if we are supplying 5 volts, I would go at least 3 times that particular voltage, right? If it is 5 volts, at least 15 volts, 0.1 microfarad capacitor, right? Or even higher, like 50 volts, 0.1 microfarad capacitor. For 3.3 as well, it also requires 0.1 microfarad decoupling capacitor. So that needs to be noted. Are there any power requirements down here? Nothing of that sort. This talks about special function register, which doesn't talk about power requirements. So let's taking a look at yeah, here, power control and sleep. Power control, external power input. It talks about CH552 has built-in load LDO 5 volts to 3 volts. It supports external 5 volts or 3 volts per voltage input referred to the external power supply. If it is 3.3 or 3 including less than anything less than 3.6, input external 3.3 voltage to the voltage regulator. So if we are giving anything less than 3.6 volts, the LDO might not be able to work as required. Okay, so it needs to have an external 3.3 regulator which is connected to the V3.3 pin, right? So sorry, external 3.3 volts to VCC pin, right? Input external 3.3 as internal working power supply. It must be connected through decoupling capacitor. So 3.3 pin should also be connected to external 3.3. So 5 volts including more than 3.6. Anything more than 3.6 volts, input external 5 volts to the voltage regulator must be connected with a decoupling capacitor to ground. Internal voltage regulator 3.3 volts output and 3.3 internal working power supply input must be connected to a decoupling. So both 5 volts should have a separate decoupling and 3.3 volts should have separate decoupling, and 3.3 volt power pin will have power from internal LDO. So we need not worry about it. So what is that we need to take out of this particular table is, if my supply is less than 3.6 volts, then we need to have a external LDO which can convert that particular power supply to 3.3 volts, and that need to be pushed back onto 3.3 volt pin, that is pin 15, pin 16 of CH552G. Else, if anything above 3.6 volts, that can be taken as VCC, and the internal LDO will produce 3.3 volts, which can be taken out from pin 16 of CH552G. So here this talks about watchdog counter, reset, wake control, power control register, things like that, which are not very important for the design per se, but they would be important when you program. How do you want to take care? Do you want to put the system on sleep mode? When should the system get woken up? Right? Things like that. So here it talks about bitwise operator or bit wake by USB. It has both read and write access. USB wake event up enable, wake up is disabled if the bit is 0. Right? So if we want to wake up that particular chipset when we receive a low signal, right, on port 1 fourth pin. So port 1 low level wake up enable, wake up is disabled if this bit is 0. So if we make this bit as 1, then wake up would be enabled, and any low level, if we pull down 1.4, then it sends a wake up signal, things like that, which is power control. So no need to worry about it for designing the microcontroller itself. External power, reset, system clock. Yeah, this is the clock diagram. It has internal clock of 24 megahertz, which would be multiplexed to 96 megahertz, right? Which would be again sent to USB clock divider at 42 megahertz, 48 megahertz, things like that, which would be used for various operations. If you are selecting external crystal, then XI/XO needs to be taken into consideration. External crystal oscillator pin needs to be enabled, and VOSC interrupt needs to be pulled down so that we get external clock, and this system continues the same, right? So that is with respect to system clock. So for CH552G, we need not worry about it, as it has internal clock. So here we have different mask system clock select. So if we select system clock, we can get different frequencies to which we can work with, right? Usually we'll be utilizing 24 megahertz, and that would be internally kept. So then there is no parameters. This we had already gone through. Maximum of 5.5 volts, internal USB level at 3.4, right? Maximum of 800 milliamps when we are using ADC, voltage comparator mode, 500 milliamps, touch key 250 microamps, 800 microamps, 500 and 250 microamps, things like that. So this is pretty straightforward. If we are operating at 3.3 volts, then the characteristics change a little bit, not too much. Right. So timing parameters, it gives various timing parameters. So that's with respect to our second chapter, where we observed that this particular chipset works with within a band of voltages, I would say, right from 3.3 volts till 5 volts, right, plus or minus 0.2 volts, let's consider. So that is with respect to power requirement. Clock requirement, it has internal 24 megahertz clock or crystal or RC circuit, whatever we call it. Then with this particular chip doesn't support external clock, so we have to be reliant on internal clock itself. So if we are using any voltages within 3.6 as its VCC, then the VCC should be supplied with that, and LDO, external LDO needs to be put in, right? So that we have both the VCC, which is the voltage below 3.6, and the LDO gets 3.3. The internal LDO will not support at that particular point. If we are using 5 volts or anything above 3.6 volts, VCC becomes anything above 3.6 volts that is used up to 5 volts, and the internal LDO kicks in, and the 3.3 volt pin gets 3.3 volts internally from the microcontroller itself, and no need of external LDO. Both pins, that is VCC and the voltage 3.3, these needs to be decoupled using 0.1 microfarad capacitor at the minimum. That is what we have seen till now. Having seen that, we can move on to the next chapter in the next video, where we will start building up the schematic for this. Thank you.